Hey, good afternoon, everybody. Thanks for being with us today. I'm Maureen with UE Systems, and today we've got Jeff Hay with RDI Technologies joining us again, talking motion amplification. It's becoming more than just videos, so some cool new things he's going to be showing everyone today that kind of building on the presentation that we did a couple weeks ago. So looking forward to hearing more about that from Jeff. Before we toss things over to him, those of you that have been coming and joining these webinars each week, you've heard this a few times now, but I'm sure we've got some new faces as well. But for those of you that are UE Systems customers or interested, we for sure want to make sure you guys know that we're here to be a support during this time where we're not necessarily able to be in the plant with you face to face, but we're certainly happy to hop on webinars or go to meetings, whatever you want to do, and talk software or instruments or applications, procedures, anything that we can help you guys help you with during this time. We certainly want you all to take advantage of that. And then these webinars that we've been doing for, goodness, almost 2 months now, I guess, kind of part of a bigger effort called Iridicio and Friends Support. So a lot of you guys know the good folks over there at Iridicio. They've been doing a lot of the webinars, providing a lot of the content, but they have a special website that you can go to, help.iridicio.com, where they've got a lot of additional resources. These webinars we've been doing are all archived there. They've got some additional no-cost project-based learning opportunities, templates, things like that, and kind of the coolest thing is they are offering for I think another week or two now some no-cost coaching hours. So if you are trying to kickstart a new project or trying to keep working on an existing one that you had going on, they've got their coaches ready to assist you and spend some time with you and help you guys along the way. So that's a really cool thing they're doing. So take advantage while it's still available. Yeah, just check out that website and I think you'll find a lot of good information over there. So, so as I mentioned, so we are recording this webinar, so we'll have it up on our YouTube channel soon and on our website, and then of course on the Iridicio site. And of course, you can check out all the other ones we've been doing as well. We certainly welcome questions. You can type those into the little questions box. I'll be keeping an eye on those so I can get those talks over to Jeff throughout the session as it makes sense, or of course we'll have some time at the end. And if we don't get to all the questions, which we normally are not able to, we've had such good participation on these events, we will definitely get all those questions over to Jeff and his team, and they can follow up with you guys offline. So don't worry, you'll be sure to get an answer. And then, as I've been saying every week, and so far, fingers crossed, knock on wood, something like that, we've been successful in not having any sudden outbursts from stray children or dogs in the house. But you know, just ignore it if that happens. And of course, if we have any technical issues, audio or anything like that, just bear with us. Part of the risk of doing these things live, but it certainly feels good to do these live and to be able to kind of connect as best we can with folks throughout the country here. So thanks again for being here. And with that, I'm going to turn the screen over to you, Jeff, and we'll let you take it away.
Okay, great. Thanks, Maureen. Okay, so yeah, the title of this talk is motion amplification. It's becoming more than just videos, and you know, the kind of idea behind that is this idea that that you know, motion amplification is a big part of what, you know, the IRSM does, and it's sort of the, you know, in some sense, a foundation of the technology. But as the, you know, cameras become more pervasive in different industries, as you know, they are within reliability and in other industries. You know, the technology increases, capabilities increase, and what you can do with them increases. And so, you know, we're fortunate that, you know, we focus on cameras, and that's an emerging technology. They've been around for a while, but they're really pushing the boundaries. At least digital cameras are really pushing the boundaries, you know, sort of in what they can do. So I wanted to while, you know, there's going to be a flavor of motion amplification in this talk, of course, I wanted to really, you know, talk a little bit about some of the other things that that cameras can do, because there's a lot more that cameras, a lot more problems or, you know, tools that cameras can do when it comes to reliability and predictive maintenance that we can leverage. And so that's what we're going to talk about here. So just a little bit for those of you who have never had the pleasure of meet or don't know who I am. I'm CEO of RDI Technologies. You know, we focus on motion amplification and camera-based technology for vibration. And my background's in physics. Started in astronomy and quickly made my way into an industry where I could actually earn a living, and you know, applied what I was doing, you know, in a different field. And so, you know, those two things may seem very different from each other, but they're remarkably similar in that the tools are the same. You know, the rules and laws of vibration and physics don't change. And so in one case, you know, you're looking at stars and they're light years away. In another case, you're looking at a motor pump that's a few feet away. And so all you can do is use the camera to get information about what you're looking at. And so we do that now with motors, pumps, you know, pipes, all kinds of stuff. So originally, a lot of the technology was DoD, defense related, for surveillance, and you know, that sort of took a life of its own. And you know, some of that came out for DHS, Homeland Security, for looking at bridges, and you know, you can see how that would evolve into vibration. And then I found my way over in condition maintenance and worked with a large service group, and to bring products to market, and you know, went into RDI full time. So it's a little bit of a, you know, a history, but let's take a step back here and just talk a little bit about motion amplification and what it is. So you'll see some videos in this presentation. I'm going to do some live demonstrations as well. One of the things that I wanted to also just point out, and Maureen sort of touched on that in the sense that, you know, we're over the internet and we're at the mercy of bandwidth and things like that. So some of you may see fluid videos, and some may see a little bit of choppy videos based on your internet connection or you know, sort of where things are routed. So just rest assured that if you see a video, they all should be fluid, and if they're not, then you can wait to get the, you know, the YouTube video if there's one in particular that you wanted to see, and that should be posted and you can watch it there. So what is motion amplification? So it's essentially turning a camera into a vibration sensor, a displacement sensor, where you take millions of pixels and you turn them all into sensors. And then we measure motion everywhere. And we do that very quickly and very efficiently. And then we can do something like this, where the left-hand side is the regular video and the right-hand side is the motion amplification video that lets you see see the motions, because once we can quantify them, we can make them bigger in the video. So sort of like what a high-speed camera does. A high-speed camera lets you see things that are too fast to see. We show you things that are too small to see. So if motorcycles are your thing, you can kind of see this. So that's a Harley under motion amplification. So just kind of relating it back to vibration, in a nutshell, this is sort of what we're doing. We're taking this concept of a spectrum, which is, you know, sort of you know, maybe difficult to understand depending on your level of expertise, right? And we're turning it into something very intuitive, which is a video. And so that's even, we're not going to focus on the motion amplification piece so much, but a lot of the flavor and a lot of the themes and the commonality between cameras and technologies is that this technology is that it allows visualization. It allows us to do things that that we can understand a little bit better, because we're not at the mercy of a single point of data collection. So you can see misalignment instead of having to say, okay, well, the ratio of these two peaks is this amount, so therefore I think maybe it's this fault. Cameras also allow us to take advantage of the fact that there's millions of pixels in the camera. So instead of there being one sensor, there's millions of sensors, and you can leverage that fact and scale up your data collection to where you're taking 2-3 million data points instantly, all simultaneously. And if you were to try to do that with strain gauges or accelerometers or prox probes, that would be nearly impossible, and even dozens of those sensors becomes sometimes cost prohibitive and certainly cumbersome. So the idea of adding 1 pixel, 2 pixel, so on and so forth, that becomes a very very trivial thing with the camera, because it's just millions of sensors in the camera itself spread over an entire field of view. Just a little bit about the technical specs. We're going to go through some just introductory stuff for those that might not even be familiar with motion amplification. Its fundamental measurement is displacement. You can do all this live. The live motion amplification. It's that efficient in how you do it. Can amplify by a lot. You can see quite a bit of small motion. Any sort of level of motion. The spec there is at less than 0.01 mils. So we're talking about really hitting any range of motion for a variety of assets that really you would be interested in seeing. That's of significance in terms of sort of ISO standards or severity charts, that sort of thing. And we show an overall, right? So that's really key too, that you can watch all motions in the scene in that video that I showed. All motions are present, or you can separate out the frequencies. We'll talk about that a little bit. And you can kind of see there the frame rate, the frequency range that it operates in. Again, we're talking about displacement, so it's really a complementary tool to accelerometers down in the range where displacements are in the lower frequency. That's where the mechanical motion is. Two measurements, and everything's in phase. All these pixels are acquired simultaneously at precisely the same time. And so that's sort of key for doing phase measurements, cross-channel phase, that sort of thing, all capable. And then, of course, we'll focus on this a little bit more. It's the shaft displacement tool, the ability to make shaft displacements and the ability to be able to see shafts move as well as inspect them. And that's another tool or aspect of cameras that we're gonna show. So I'll talk a little bit in this talk a little bit more about the CM than I will than I have in previous talks if you've watched them before. But this is sort of the delivery system, right? That's the kind of way I look at it. You've got the Iris M, and then which is kind of the standard sort of camera. You can think of it as a standard camera that does the majority of the work. But if you ever need to go high speed, high frequency, the MX does that. That's really what that does, is it sort of allows you to go higher speed if you need to be able to see things that are moving faster. It has a higher frame rate in a nutshell. That's really what separates those. But the CM is sort of a different animal. Really, that the CM stands for continuous monitoring. And one of the reasons why I want to focus on that is because it can do things. You can do things with cameras that are pretty interesting when you start to do things like continuous monitoring. I mean, you can imagine, a lot of work is being done today in surveillance, and so you can see, there's 3 people in the field of view. This person entered from the left, this person entered from the right. The same person shows up in the video 5 times. There's a lot of work being done with continuous monitoring. We think of it as looking at a machine, but the entire world is using cameras in automobiles to pilot them and things like that. So I'm going to talk a little bit about that. That just sort of goes beyond to traditional motion amplification. A little bit about motion amplification, some of the benefits. We won't go too much in detail, but you can imagine a lot of these come from the fact that you're using a camera. So it's a root cause tool because you can cover such a large area in such a quick amount of time, and be able to look, really do a comprehensive look. It's a communication tool, produces videos, a non-contact, and you can do it while things in operation, that sort of thing. So it lends itself to very diverse application set. And then I generally think of the camera more of setting up like a GoPro than I do of setting up sort of an analyzer, where it's really, in some sense, point and click. You focus it, you set the lighting, and then you move on. So really easy to use. I'm going to do some live stuff, even where from acquisition all the way to analysis here in a short bit. But again, actionable information. I mean, that's one of the things that I'm always about. If you can't do something with the information that you gather, the information doesn't have a lot of value to you. And so the key point, I think, with any technology is that if you can make an action based on it, that technology has value to you. If you're going to do something about what you see. So again, you can imagine there's a lot of variety of anywhere from structures and roller coasters to wind turbines and just simple motors and pumps that are pervasive everywhere. So just if you're a traditional vibration person, this is going to look familiar to you. Maybe this is your route where motor pump combination, or maybe a motor blower combination. You go through in this situation and you take, vertical, horizontal, axial, inboard, outboard, and you do that, right? And that gives you a lot of information about that asset. But the idea with the camera is you blanket this thing, and even a camera would be more thorough than this diagram that we've drawn, because every pixel, there's no gaps. Everything is collected, and so that's kind of the idea that we're doing here. And then I mentioned before, you can filter. So here we can show, I said you show the overall video motions in the videos, but here we're picking out 3 individual frequencies, and we're only going to show those. We're going to only show those frequencies. And let me give you a little bit of an example. Let me give you a little bit of an example of that here. This is a video where there are 3 dominant frequencies in the video, and we're going to go through and just kind of demonstrate how with this you can kind of go through and show that you can look at individual frequencies, right? And when you do that, faults manifest at particular frequencies, so it gives you a particular interesting look at it. So here we're going to isolate, sort of that one frequency on the pump, and sort of demonstrate how you can isolate that one frequency. And now, if you remember the first video that you saw, right, you were seeing that the 2 screens were moving and the pump was moving. Now watch what happens when you play back here. You can see that the only thing moving is that pump. So you can see center of the screen right behind that attention sign. You can see that that pump is the only thing moving, where in the pipe that's connected to it. But again, we filtered out those other things. So if you want to sort of behind the scenes look, there's that's what we're looking at. You can sort of see the motor there along with the pump. You can see all that pipe work, excessive vibration, and then we're going to isolate the individual screens here to show that. So we're going to filter for one screen, and then we're going to filter for another screen. So here's one, and then again, all same data set, all coming from the same one. And so now we're going to go to that second screen. So again, what I wanted to do is just demonstrate sort of the ability to show, different frequencies, because it's a very important part of this, just to set up the background. Again, we're showing this overall, this motion of this motor here, and then we can filter for individual frequencies, like the 2 hertz of the band of the output of the gearbox, or say, the 25 hertz for the motor, or say, something, in the background, like the 4 hertz on this conveyor that's bouncing in the background, which actually ended up being the real issue here. And then the final thing I wanted to just point out, and then kind of the setup here, is the concept of stabilization. And I talk about this because inevitably this is a question that always gets asked in every presentation I give. So I always make sure I put a slide in, no matter what the topic is, because people say if you're on a move on your shaking ground, what do you do? And so, well, there's some things, passive ways that you can remove it, and that's all good. But sometimes it's just too much even for that. And so there's active ways that you can go in and stabilize. So here you can see this box, and I'm telling that software that box is not moving. What's in that box? That's the ground. And it anchors to that. So it has built-in capabilities, and that's important because even though you can filter out some motion with frequencies, lots of times the ground is like a complete transient or broadband noise, and you really need stabilization becomes an important piece. Here I'm just showing a few videos that demonstrate that concept of stabilization. This was on a roof of a building, and so of course you're going to get vibration, and the ground's gonna shake because you're on a moving sort of platform, which is the roof. So again, just kind of walking through this setup, and then now we'll get into the sort of the meat of the presentation, which is really the topic that I wanted to talk about, which is more than just video, right? So we're going to go through sort of these series of capabilities that the camera lets you do, that are not just the sort of the MP4 video that you may share with somebody or play on your phone or something like that. Just that self-contained video, some other things that allow you to understand it than just the motion amplification videos themselves. So this first feature actually has motion amplification in it, but I want to talk about it because it's a little bit different than just a video. I'm going to do a live demonstration here. So I'm going to turn on a rotor kit here in the office, and then we'll do it from that. So. Okay, so I'm going to launch the acquisition software here. And then I'm going to bring that over onto the screen here. Just going to, kind of square that up. And then, so, the reason why I'm talking a little bit about live motion amplification is because this is, this isn't just producing a video. This is really about troubleshooting in the field. And what it's about is just this idea that you can press this button and go straight into live motion amplification. So this is occurring live right now. I'm gonna put my hand in front of the camera here just to kind of show you that, right? Show you that the concept that it's live. And so I wanted to go a little bit more in depth on this topic for this presentation. You can increase the amplification, right live if you want. You can even slow it down. So if something's moving too fast, you can slow it down. So you can imagine how this tool could be used. Not just about producing a video, but as an understanding tool in the field to be able to see what's moving live, in very complex fields of view. So you can, the idea here is that one of the things when we started doing motion amplification with the IRIS-M, and I was exposed to this industry for the first time, I had heard that a lot of people say, I wish I could do an ODS on that, or a complex analysis, or a real sophisticated look at this asset. But I can't afford to do that because it will take a half day, or to take a day, or to take or maybe it's I can't get it in the sort of budget to bring someone in to do that level of analysis, because this asset doesn't have high enough criticality, or it's not valuable. And so one of the things that was interesting about motion amplification is what really we wanted to do was really allow the bar to be lowered there, so that if you weren't able to afford to be able to spend a half day on an asset, maybe you could spend maybe you could spend, you know, an hour on an asset or 30 minutes on an asset doing sort of motion amplification study with the camera, because the camera allows you to do it so quickly. Again, coming back to this idea that, you know, a camera is opening up a lot of doors. And so what my point is with live amplification, what we're trying to do here is, again, lower that bar again one more time, so that now, even if you can't afford to spend 30 minutes or an hour on an asset, maybe you can afford to spend 10 minutes or 5 minutes or 10 seconds, you know, where you can go through and say, okay, you know, I'm just going to stop by, I'm out doing a scan, I'm going to stop by and look at that, you know, quickly, because I'm walking by it with the camera. And so that's the sort of thing that live motion amplification, we're excited that you know, that would open the door for. So again, let me go through and show you a few videos here, just kind of demonstrate that. I guess I got ahead of myself, and I was supposed to show you that demonstration after the slide said demonstration. So here is a video of a network of pipes, right? And then now we amplified the data. I'm going to turn off that rotor kit. And we amplified it. And the idea here is that, you know, where do you start, right? Where do you start in a view like this? How do you you know, make, you know, how do you make a judgment call on, like, you know, I'm gonna put an accelerometer on that, right? You know, and even if you can put an accelerometer on that, and the answer is largely you don't, right? People don't monitor a lot of pipe work. There's a lot of things like that that sort of just go unmonitored because there's either too much of it, it's too complex, or there's just not the appropriate tool out there for it. And so that's the idea also with being able to look at something live like that. Again, it's because we have a camera. You know, it comes back to this idea that the camera enables us really to be able to do something pretty sophisticated. So, and then this video, you know, you could catch something like this live, right? You just have lots of little things out there, right, that are of high consequence. You know, you can do these scans. And so this is the idea behind sort of the with the live amplification for scanning, you know, in terms of just going beyond to traditional, I'm going to collect a data, write a report, and that sort of thing. Okay, so let's talk a little bit about shaft displacement and inspection. I'm going to turn on the rotor kit once again. And so this again is you know, sort of unrelated. This is a little bit definitely from any sort of motion amplification in the traditional sense. Let me talk about that just a little bit. And so what I want to talk about here is the idea about, you know, using this in a different, in a new way, right? In a way in which you can get at sort of shaft measurements and also inspection, right? So you can go through and utilize a camera to do some things with the couplings and the rotation to be able to do and measurements on the shaft itself. So let me I think it's a demonstration again. I'll wait for the demonstration slide here. A demonstration is much better to show this. So let me bring this up. First I wanted to show you this concept of speed detection, right? So once you understand the speed, you can do interesting things with it. The camera can actually determine the speed of an asset, right? So we're going to do that. And I'm actually going through right now and using the camera itself to calculate the speed of the asset. So here it calculated 1499.27 RPM. You know, I kind of know this asset. I'm saying that's acceptable. I'm happy with that, right? And so now we have the speed of the asset put in. And once you have the speed of the asset put in, you can do some pretty interesting things with the camera. So the first thing I want to show you is this idea of shaft inspection. So this is actually just an inspection tool in and of itself. Let me go into that. So I'm going to change the acquisition type, right? So I've inputted or actually I've measured the shaft speed here. and then I'm going to go into shaft inspection mode. So this is going to go into a specialized mode that's really designed about inspecting the shaft, inspecting couplings. You'll see inspecting chains, you know, and different assets. And so you can see now that I can actually see the shaft, even though that you shouldn't be able to see it, right? And I'm going to do a recording here. And the idea behind this is to be able to inspect right on the spot, be able to inspect things like couplings and shafts. And so here, I'm going to play this back, right? But what you'll notice is we have this incredibly high resolution on the inspection. I can go through on the shaft inspection. I can go through and actually spin the shaft around and then look at it, right? And so what's really nice about that is the ability to be able to do this on the spot in the field and look at couplings and things like that. Now, you know, there are other ways to do this, and we you know, we all know that there's you can do a strobe and that sort of thing, and that will get at this too. But what's nice about this is, one, you don't need another tool, and two, it's sort of like just an additional evaluation you can do with the camera. It also provides a record, so it's really easy to have this data that you can then take back and have a video recording of that. But the last thing I wanted to mention about this in relation to a strobe is that if you move away from the asset, it doesn't have, there's no consequence. And in other words, with a strobe, as you move away, you know, the light diminishes. And if you've ever used a strobe, you know you have to be pretty close with the strobe to be able to see it. And you don't have that issue here with shaft inspection. And so, again, I just wanted to demonstrate that and show that, because this is a really easy way to be able to go through and then capture this and record it, and also have it for recall at another time. And so we can actually go through, I'm going to go through and kind of show some videos here of some component inspections. So this would be, you know, sort of a, not just shafts, but anything that's rotating. So this would be the sheave here that we've locked into that frequency. And then we're going to look at the other sheave here to be able to lock into to that frequency. So again, you can inspect multiple components with this throughout it. And then the other thing, and I'll kind of, while you're watching this, I'll just speak to this. We're getting the belt here. You can also do inspections with, you can also do a displacement measurement as well on the shaft. So you can actually measure the operational run out of the shaft in addition to just this inspection. So you can quantify the motion of a shaft when you're measuring it, right? So here are all of them together. We have we have our own little video editor that allows you to produce these quadrant videos. We'll talk about that in a little bit. Okay, so let's do this next one we'll talk about here. So this is, again, a shaft inspection tool. We'll talk about the displacement measurements too. You can actually draw boxes on these shafts and actually make a measurement of the shaft as well. So it's kind of like operational run out. You can get the displacement. So again, doing this with the shaft. Now here's the measurement tool. We haven't talked about this or shown this yet, but see how we draw the box there, and we can actually measure the motion while it's running with a camera. Again, this is all leveraging the fact that we're using a camera to be able to do that. So let me show that one more time there. We're actually able to measure the run out there of the shaft itself. Again, non-contact, right? You can't make contact, and we're leveraging the fact that, you know, a camera can measure this without actually having to make contact, which would be impossible. I mean, similar to what a prox probe does without having to, you know, affix any sort of thing to the asset. So again, just kind of going through some of these tools. There's again shaft inspection. Here's a damaged coupling. And then here's that other shaft that you saw before with another look. So again, just wanted to demonstrate this, you know, in the sense that, you know, it's really the camera that's allowing us to do these new techniques with visualizing it and getting sort of this high resolution look. So here are some belts slipping, so you can lock into the sort of the belt frequency. So here's the shaft measurement. Here's a demonstration of it. So we pick a type of shaft, a horizontal or a vertical shaft. And then we go through and we draw a box. Really, it's really that simple. You draw the box there, and then it measures and calculates, and then you can actually go through and do it on the other side here of the coupling, and then we're going to make 2 measurements, and then you can actually see, you know, they're demonstrating the peak to peak. So some of these videos, we've some of our partners, you'll notice other logos on there, like this is RMS. Some partners from around the world, and some of our partners here in the U.S. and customers as well have provided nice videos for us to use. We appreciate that. Okay, so let's talk a little bit about motion vectors. This is a tool that I think is interesting, that you can sort of leverage. You know, again, going beyond just the motion amplification, but leverage it to be able to show motion in a different way. And so I'm going to pull up a rotor kit beam. This is a machine vibration trainer that has a cantilever beam on top. And if you notice here, we put all these boxes. These are called ROIs. We won't go into the details of that here, but just know that these are all measurement points that you just drew a box around, and it made a measurement for you. And you can turn all of those into vectors. And I'm going to play this back. I'm going to slow it down just a little bit. And you can see all these vectors moving, and the length of the vector has to do with how much it's how the amplitude of the motion, and the direction, of course, is the direction. And so again, this is live in the software. So we're showing this. I'm going to show a filtered data set. So then what we've done is we've isolated these modes of vibration. And so I'm using these vectors to be able to demonstrate, you know, that the end of the beam is moving more than the sort of the fixed location of the beam on the right hand side. And what's interesting about this is that we're not showing motion amplification. I mean, I could do that. I could increase the amplification over here on the slider on the right, and you could show that. But what I wanted to demonstrate is the ability, you know, to be able to use other tools besides motion amplification in this to show you that you can draw these vectors anywhere you want. You can pick individual locations. They're able to, you know, really clearly and concisely show you information on the screen. I'm going to keep going through these different modes of vibration because I think it's interesting. So let me play this back, and then I'll slow it down again because we're getting progressively faster and faster on these. So notice you can immediately see that this one looks a little different. It's a third mode of vibration, but it's actually got a little bit of a right-left motion to it because this beam's sliding. And again, we could see that in the motion amplification video, but the vectors do a really good job. And once you start to get to these high modes of vibration, you can start to see things like the nodes and the antinodes. And so that's pretty interesting. Let me just kind of get a still here. Right here, you can see this shape, right? The shape that goes through. And you can see phase really well. And that's one thing I really wanted to make sure I pointed out, that this is a very easy way to show phase. So you can go through and you can show these nodes and antinodes really easy. And what's interesting about that is you can kind of see the significance of where you were to put your sensor. So these things make it really easy to visualize that and sort of make sense about, even if you use this, you know, as a tool to maybe decide if you're going to use strain gauges. Where do you put your strain gauges? You know, where do they go? So anyway, the concept of motion vectors here on this one, and then finally, let me show this last mode of vibration just to kind of bring it back here, and then so this is the fourth mode of vibration. Again, you know, the vectors are really demonstrating this concept of directionality and level of motion, and also the shape of vibration, kind of a complex way of being able to show that. Let me bring this into a a real asset, right? So I'm going to bring this over to a coupling where you can show sort of phase, right? So if we were to play back this amplification video, you would see the motion go up and down, up on the right side while the left-hand side's going down, right? So they're out of phase, 180 degrees out of phase. And so in traditional vibration, we represent that in different ways. We might do cross-channel phase with 2 accelerometers and then say, they're 180 degrees out of phase, give you a number, 90 degrees, 180, right? And that number tells you something. I think that's, for me, that's the least intuitive, sort of in a scale of things. And then the next, in sort of being intuitive, you can overlay 2 plots to show, the graph on a plot, one's going up while the other's going down. But for me, I think the most intuitive is just to show one arrow pointing one way and another arrow pointing another way, and even better to be able to show that over time. And so that really tells me very easily that, one side is going up while the other is going down, though we're out of phase, and that's a problem. Again, you could always motion amplify this, right? And it would, support that, the right-hand side's going up while the left's going down. But the vectors, in my opinion, are a very, very easy way to be able to show that. So let me just walk through some, again, kind of doing the, I get ahead of myself. I need to wait for that demonstration slide. Show a few videos here that are demonstrating the vectors and just kind of in industry, right? Some real life examples of that. So here is in the automotive industry, the use on motors, and again, no motion amplification involved here, plots and the vectors. And what's nice about this is, you can really distill it down to a few points if you're really trying to hit home this idea of the way things are moving relative to one another. So if motion amplification, for example, is showing you sort of a really complex field of view, you can show it really simply with these vectors. And then here is a rail car moving. And what I like about this, you can see the vectors progressively go down, as that goes in that direction, right? And so it's pretty interesting to be able to see that the motion and the way that responds. Again, no amplification, right? And it's also interesting to see them go up like that, because when that train comes on and actually forces it down on the right, it sort of bows up, forces the rail up on the left-hand side. So again, just really easy to distill it down. Here's with motion amplification. You can actually see the track kind of depressed there as that train comes through. Okay, let's talk about transients, right? Transient ROIs. So I'm going to go straight into a demonstration here. Again, I'll wait for the slide there. So let me show you this. This is I think a non-typical asset to be looking at with vibration equipment. This is a robot arm, right? And traditionally things that vibrate move about a fixed location. And so what I'm going to show you is this ability to do something more with the camera, because we're capturing, you put an accelerometer on something and it is sort of bound to that location, right? But we've got a lot more information in the camera. We can do a lot more with it than just sort of a vibration about a fixed center. So what I want to show you is this idea of being able to do transient ROIs, about making a measurement of something that's transiting the scene, right? And so here, let me play this back and show you what we've done here. This type of measurement allows you to track an object through a scene and show you what the motion looks like, right? So this motion is overlaid on this, and you can actually see it, and you can pull out information. You can pull out information that occurs, the overall motion, or you can pull out information that occurs, sort of inside that box, and then also spectral data from inside that box. And then of course you can show the overall motion too. But this goes beyond the traditional, again, beyond traditional motion amplification. But really, we're leveraging the fact that we can see objects transiting and measure them, right? And so the idea here is, again, leveraging the camera. You can get spectrum from moving objects this way. So let me go through and show a couple of videos here showing sort of the transient path and the waveform, sort of the vibration in the object. So if you need to be able to do sort of analysis that is requires you to be able to measure an object that's moving through the scene, you can use this technology to do that. So there's sort of the motion as it's traversing through. Again, you can see the deviations inside that box to be able to see how stable is that motion. Is it sort of vibrating? Is there points that it's altering from its course in these sort of impacting in these waveforms? So tracking, really anything if it's moving and you can see it. So here's kind of putting it to task, tracking a helicopter. You can see it sort of dip there. This was kind of serendipity to be able to grab this shot. But sort of non-traditional assets and be able to understand their motion, right? So again, here's the time waveform. So that's really the vibration occurring inside, and you can see the impacting there, and you can capture that impacting in that time waveform because it's measuring sort of those events that are occurring inside the path. This also has transient motion amplification that we'll speak about here in a second, but kind of just hitting on that theme of transient. So here's a barge, and you'll notice that he's pulling here spectrum off this. So he's measuring in different locations on this barge as it moves through and pulling off frequencies as it moves through, right? So again, frequencies of moving objects, and then just a little bit of tongue-in-cheek here. Some of our partners have got pretty creative with during COVID when they're sort of locked up, and so we, clever little motion analysis. You can pull out your Roombas and measure them. So transient motion amplification, I'll touch on that just quickly here, but it's the idea that just to kind of couple to this idea of motion amplification, you have this big, this goes beyond normal motion amplification, because when you amplify something that's already moving a lot, this thing actually moves through the scene quite a bit. So when you try to handle motion amplification of a large object, if you amplify that, it sort of blows everything out because the motion's already big. And so, now you can actually, choose to just be able to amplify small motions as well on top of large motions and give them sort of preference. So you can actually see those small little motions that occur on a very big moving object. And so I'll show a sort of a real life example of that, where you can actually see these, sort of those bumps when it's vibrating as it moves that you normally would still not even be able to see, even with traditional motion amplification. So talk a little bit about Motion Map here. This is sort of a new tool to be able to visualize. It's a new tool to be able to visualize motions on a scene. So let me bring up a demonstration here, a live demonstration. We looked at this. We know that there's 3 major frequencies in it. I'm going to turn on this tool called Motion Map, and what it does is gives me an overlay of motion in color with sort of like a thermal image, but distilling it down to red is more intense and blue is less intense. And I can actually analyze, and this is really what I want to show you, analyze individual frequencies in this scene. So I'm going to go through and just pick a frequency here, and then look at that right in the scene. And I can actually just look through this entire series of data and see, you know, in these colorized images, what's going on. This is one of the quickest ways that you can go through and analyze motion with these motion maps. So what we're doing is really doing a color overlay of motion only at a particular frequency. This is the motion occurring at only 14 hertz. And this is the motion occurring only at 15 hertz. And this is the motion occurring only at 8 hertz. And one of the things, let me point out one of the things that you can show here. Look at the way that you can see the way in which the vibrations kind of propagate through this railing all the way down, right? If you show the motion on the nearby one, you can see that they fall off pretty rapidly. So, you know, with this quick assessment tool, you can actually get a very quick visualization of motions, you know, in a very easy to understand way. So here is, you can kind of see that, you know, in fact, that if you look at this screen here, you can see that that the vibrations fall off here, even though this is a nearby screen, you know, to this railing, you know, kind of getting levels of green. But if we go over here, you can see, you know, levels of red. So this screen is actually vibrating this railing more than this one is, even though it's right next to it. So it kind of clues you in, maybe that it's coupled, or maybe it's coupled to it, or maybe this prefers this mode of vibration. So you can do, you know, you can do some interesting things. You can change the overlays so that you're only showing sort of this motion at a particular frequency. And now I can play this back and show sort of the motion amplification with it. Again, not to focus on the motion amplification, just know that this can be supplemented to show an overall video of motion, which is the motion amplification video, and highlight individual frequencies at a given time. Let me show you one more structure that I think is interesting. I'm gonna do a motion map of this structure. And I really like this because, you know, one of the ways that I sort of use this is to go through and just investigate a data set, right? So if I go through, I can actually go through and start scanning this and picking up on individual beams within a structure like this, and to figure out, you know, what frequencies they're moving at. What I'm doing is I'm scanning through the different frequencies here, and just looking at all the different components that are popping out in the scene at the different frequencies, and, you know, getting a level of understanding. So again, this motion map is a really quick way to be able to get at you know, understanding motion. And the last thing that I wanted to talk about is this idea of continuous monitoring. You know, with a continuous monitoring system, you know, like the CM, you can place 3 cameras out and configure them all, set them up, and leave them. You know, you can configure them much like you do a normal camera, set them up and turn them on and run them nonstop. And you can set up triggers with an individual ROI, region of interest. So you can draw a box here, and the camera now can monitor that location in real time continuously with simple preset levels, and trigger off 1, 2, or 3 cameras. You know, you could tell one camera to fire off all the cameras, and you can monitor assets this way nonstop with just with the camera. You can set, you know, timer triggers, accelerometer triggers, you know, all that. But I wanted to really focus on the camera portion of it, which is the ROI, where you can draw this box and monitor that in real time. Monitor that box in real time for motion, right? As if there was an accelerometer placed on it. Again, timer triggers. And you can even do live amplification. You know, you could have this camera set out and in your office, press a button on a screen and show live what that camera is doing right now, what that asset's doing on the camera. And so just kind of show you really quick what's been done with it. This was in a lab configuration a test where they were testing this elbow, and they wanted 3 cameras on it simultaneously. So you can see again, we in the software we created this multi-view of all 3 cameras. This is an image where we put an image in this 4th quadrant. 3 cameras all simultaneously collecting data, and they were exploring different changes to the structure so that they could to this elbow, so that they could decide upon what was the right fit. So they would go through, and they wanted to be able to capture all these things individually, simultaneously. And so they used this continuous monitoring system to be able to do that, all through these different configurations. And then it was also ran overnight and actually triggered off of these. So these are 2 camera view, triggered off these events where they were captured a support that was loose because it went through an elevated level of vibration. And so we'll see that here in a second, where this support gets loose. So again, this is just not, what the point of this is not to necessarily focus on the motion amplification. It's the idea that you can set this camera overnight like this and capture things like this, right? Without being there. Let it do the work for you. I don't want to know unless it gets above a certain level of vibration, with these, and all done with the camera. And then again, this was a remote facility where they were having problems with the pump, and there was a coast down, and they were capturing it. Again, a long recording here to go through these this event. But of course, no one manned this. This was a remote building that no one was in, and this was a 70-foot long shaft that ran down to collect water on a vertical pump. And so this was nice because it gives you the ability, the continuous monitoring can do, 90 minutes worth of video, it stores that. And so any point in time, this was what we call an extraction. So 90 minutes worth of video are constantly, like a DVR, it's just overriding buffering. And so, operations calls in and says, hey, we just did the coast down. Oh, you did it 30 minutes ago? Yeah. It's not always coordinated with operations. And so they went in and actually extracted this video for the proper time, and then just got the coast down. That simple, right? So again, in this case, they weren't relying on the. I'll speed this up so you guys can get to the main event here. But they weren't relying on the fact that it was triggering. They relied on this extraction process to be able to see this event and then pick it out and then go through. Of course, they could have triggered off that because you can kind of see that waveform. So again, just getting back to this idea that cameras allow you to do a lot of different things. You can put a lot of things in context with 3 cameras continuously monitoring an asset. So again, I just want to stop there where I think I ran right at the time. And we can take a few questions here, and then again, if we can't get to all the questions, we'll answer those afterwards as well. Get back in touch with you.
Yeah, awesome. Well, great presentation, Jeff. Thank you. And those of you that were looking for, slides and some of the different information from this, definitely best to get in touch with Jeff. So make note of his contact info there. Of course, you can also reach out to me, and I can easily get you guys in touch with the folks over at RDI. A lot of the questions, Jeff, I think are really much more specific to people's applications that they have. So probably best for you guys to just handle those one-on-one with everybody, but definitely generated a lot of interest, and you guys should have some good follow-ups to make. So with that, I am going to just grab the screen real quick and just share a couple closing slides, just to make folks aware of some things we've got coming up. Oh, and I did this last week too. So we've got another webinar tomorrow. I don't know why I removed it from this slide, but Sean Eisenhower with the Arditio is going to be talking basically root cause analysis. Definitely one of his kind of passion topics. So if that's of interest to you, we've got the link out various places, LinkedIn, things like that, and also in the invite. But we can, if you are interested and you didn't get that, you can shoot me an email and I'll get the link sent to you. So that's tomorrow. And then next week, we're going to have 2 more webinars. We're going to have James from Arditio talking about making sure your work gets done. So he's really big on work orders and work management, things like that. So that should be a really good webinar. And then we're going to take the reins next Friday and talk electrical safety with ultrasound. It's apparently Electrical Safety Month, so we thought that'd be a great topic to share. So look for invitations for those coming out on Monday. And again, don't forget tomorrow we will do some root cause analysis with Mr. Eisenhower. So with that, I'm going to put our info up here and we'll let everybody head on out for the rest of your day. Thanks for being with us. Again, thanks Jeff and the great team over at RDI for working with us on this webinar. And we hope everybody has a great afternoon and everybody stay healthy and safe, and we'll catch you guys later.